Thermodynamic systems. The word system has a very specific meaning in thermodynamics. We'll be discussing what it means. We'll also discuss how to classify different types of systems. The system is anything that we choose to study. It can be a piece of matter, or it can be a region of space. Everything outside the system forms the surroundings. The boundary is the surface that separates the system from the surroundings and is denoted by a dashed line. A closed system is one in which the mass of the system is constant. So an example is a rock. Once we draw a boundary around it, the mass inside the system does not change. However, energy can cross the system boundary. For example, we could heat the rock. A closed system is also called a controlled mass, and we shall use the two terms interchangeably. Now, the system boundary may move, so if the rock falls, the system boundary moves along with it. The system boundary can be a purely imaginary one. For example, we can select an infinitesimally small volume of the rock and define that as our system. We will be doing this quite frequently, and then we can do a mass or energy balance on this small volume and integrate it over the entire volume of the system. The location of the system boundary is very important. So if we are heating water on an electric stove and we want to analyze what is happening to the water, we may choose to put our system as just the water and put the boundary around that. If we decide that the thermal mass of the container is also important, we may choose to put that as part of the system, and then we'll draw a system boundary around both the water and the container. Now, in some cases, we may choose to put the heater also inside the system boundary. The difference in these cases is that in the first two, when we analyze what form of energy we are adding to the system, it is going to be heat. But in the third case, the energy that we are adding is electrical energy, because the energy that crosses the system boundary is the electric current, and that is converted to heat within the system boundary. And as we'll see, it will make a difference in our analysis as to which one we choose. Now, the system boundary may change its shape and size. The system over here is a cylinder containing gas, which can be compressed by a movable piston. The system we have defined is just the gas. But as the piston moves, the system changes. But the mass inside the system remains constant, and therefore this is an example of a controlled mass. An open system is one in which both energy and mass can cross the system boundary. So we have over here a water pipe, and around a section of that, a heater coil is wrapped, and we use that to heat up the water. Now, if we want to analyze the temperature rise of the water as it goes through the heater coil, we will define a system which is just the heated portion of the pipe. Now, in this system, there's mass which is both going in and it's coming out of the system. We also have heat being added to the system. So this is an open system, and this is also known as a controlled volume, and we'll be using both of those terms also interchangeably. Now, a controlled volume may move through space. So over here, the controlled volume is drawn around this rocket. As the rocket travels, the controlled volume moves with it, but the exhaust gases which are ejected cross the system boundary. So there's mass crossing the system boundary, and therefore this is a controlled volume, not a controlled mass. Finally, an isolated system is one in which there's no mass or energy crossing the boundaries of the system. So, the system is sealed so that there's no mass transfer across the system boundary. It is rigid, so we cannot compress it and there's no work transfer. And finally, it is perfectly insulated so that there is no heat transfer. An isolated system, therefore, does not interact with its surroundings. Most importantly, the properties of an isolated system, once it is at equilibrium, will never change because the surroundings cannot affect what is going on inside the system. To summarize, a system is any piece of matter or region of space that we identify for purposes of analysis. A closed system, or a controlled mass, is one in which energy can cross the system boundary, but not mass. An open system, or a controlled volume, is one in which both energy and mass can cross the system boundary. And finally, an isolated system is one in which neither energy nor mass can cross the system boundary.